So today we're going to be doing something in Calculus 3 that involves space curves. With space curves, we're going to be particularly examining vector functions, derivatives, and integrals, and the tangent points. And we're going to be doing exercises with vector curves. So first thing before we get started is note that a vector function basically you put in a position for t, a parameterization for t, and your output is a position vector, essentially. That's what a space curve is. So consider the vector function or the space curve r of t is equal to root 2 sine t, 1, and cos t. Question A, give the vector function of the line L of s that is tangent to the space curve r of t at t equals pi over 4. Choose a parametrization L of s where s equals 0 corresponds to the point of tangency. B, let OP and OQ be r of pi over 3 and r of pi respectively, and determine the vector QP and its magnitude. And part C, find a vector function q of t where dq dt is equal to r of t and q of pi is 0, 1, 0. So let's tackle this one at a time. Part A. Sorry, I accidentally clicked something on my pen. So let's the way I like to find the vector equation for the point of tangency is I do something like this. So I accidentally clicked something on my pen again. So the way I do it is r of a, this is not the same thing of r of t, this is like the parameterization for tangency, is I do it like r of a plus t r prime of a. This is the way I do my formula, and I'm going to apply it here, except we're asked to use s, so I'm going to be using s as opposed to t. This is how I do it. So first I'm going to investigate what r of pi over 4 is, since our a is equal to pi over 4. So r of pi over 4, that would be equal to root 2 times 1 over root 2, that's 1. So just plug in pi over 4 into r of t. So 1, 1, and cos of pi over 4 is 1 over root 2. R prime of t, we need to find that as well. Derivative of sine is cos, so that's root 2 cos t. Derivative of 1 is 0, and the derivative of cos t is negative sine t. R prime of pi over 3. Wait, sorry, am I supposed to do? No, pi over 4. Sorry, I don't know why I said pi over 3. That was a quick slip of the tongue. Pi over 4, that would be equal to, so just plug this in. Root 2 cos pi over 4 is 1. 0. Negative 1 over root 2. So based on this r, I should have said L, but basically L of s, for the vector equation that is tangent to r of pi over 4. So I say L of s, this is the tangent line for the vector equation at pi over 4, is equal to this original point, 1, 1. It doesn't matter if I do this brackets or like this. It's the same idea. 1, 1, 1 over root 2 plus s And then this 1, 0, negative 1 over root 2. But we're specifically asked to do a parameterization. So I'm going to do this. This is the vector equation, but we want parametric equation. So x is equal to 1 plus s. Y is equal to 1 because there's no s. And z is equal to 1 over root 2 minus 1 over root 2s. And that's the answer. Notice that at the same time, when I applied this formula for the tangent vector for the vector equation, I simultaneously covered the parts where s equals 0 corresponded to the point of tangency. And you can actually see that this works in my solution because at s equals 0, you have the initial position vector at t equals pi over 4, because L of 0 is just 1 over root 2, which corresponds to this position vector r of pi over 4. So yes, that's the correct answer. Part B is just testing your knowledge of vectors. Now, before I answer this question, I'm going to indirectly answer this by drawing a diagram. So let's say OP, this is not drawn to scale for the record, OP, and OQ, so like both vectors have a starting position at O. Again, this is not drawn to scale. And QP looks something like this. Okay, this is QP. It starts at Q and ends at P. This starts as Q here and ends at P here. You know what? Maybe I'll even do this. O. This is O. I'm gonna put bracket around it. This point is O. This point is Q. You start at Q and you end at point P here. Now, if you've taken like physics or like some linear algebra, you would know that when you're like adding vectors, I'm gonna write a note here actually. So basically, rule. When adding vectors, you take the head of the first vector and you connect it to the tail of the second vector. And your sum goes from the head of the first to the tail of the second. It's like head of the first here, the head of, so basically what that means is applying that here. I'm going to erase this. So that means here we have OQ plus QP is equal to OP. Because the first vector is OQ, the second vector is OP. I took the second vector's tail and connected it to the head of the first vector. And my sum is from the head of the first to the tail of the second, which is OP. Now, we are told that OP is r of pi over 3. So OP is equal to r of pi over 3. And that is equal to, so let's see, root 2 times root 3 over root 2. is root 3 over root 2. 1. And cos of pi over 3 is 1 over 2. Okay. And the other one is r of pi, which is o cubed. And that is equal to r of pi, yeah. Plug that into the vector equation here. That's 0. This sine of pi is 0. 1. Cos of pi is -1. Okay, so that means QP, I'm writing this slowly so you guys can understand, is equal to QP is just equal to OP minus OQ. So OP this minus this, so that's root 3 over root 2. One minus 1 is 0. And 1 over 2 minus -1 is 3 over 2, not root 2, 3 over 2. And we're asked to find the magnitude of this vector as well. Okay, so that is equal to 3 over 2, because this squared is 3 over 2, plus 0, 3 over 2 squared is 9 over 4. That is equal to, let me think, 9 over 4 plus 6 over 4, that's 15 over 4. Root 15 over 4 is root 15 over 2. That's the answer. That's the magnitude of QP. And lastly, part C. So Q of t, the derivative of Q of t is R of t. That's the same thing as saying Q of t. If the derivative of Q of t is R of t, then Q of t is the integral of R of t. Okay, and the integral of R of t, we just integrate each component of the vectors here for R of t. So that is equal to root 2, negative root 2 cos t plus c1. Here, it's just t plus c2. And sine t plus c3. Okay, now that is Q of t, and we're also told that Q of pi is equal to 0, 1, 0. Okay, now this corresponds to each component. We write it like this. So negative root 2 cos t plus, actually, you know what? Yeah, so Q of pi is 0, 1, 0, right? So negative 2 root 2 cos pi, I'm going to dumb it down for you guys, plus c1 is equal to 0. This is root 2 plus c1 is equal to 0. So c1 is equal to negative root 2. Yeah, that's right. Yeah. Okay. T plus c2 is 1. Ugh, I forgot to say pi plus c2 is 1 since we're doing r of pi. Pi plus c2 is 1. So c2 is 1 minus pi. And last but not least, sine t plus c3 is 0. Or no, sorry, sine pi is at pi. Sine pi plus c3 is 0, but sine pi is 0. So c3 is equal to 0. Plugging all this in, we get q of t, the vector q of function q of t, is equal to negative root 2 cos t minus root 2 t plus 1 minus pi and sine t. And that is the answer. We are done this question for today. So hope that was really helpful and gave you some insight on what could be asked for you about space curves. Just know that the key takeaway is a space curve is a function where the output gives you a position vector depending on your parametrization value of t, and that the derivatives and integrals of each position vector, you take the individual components of x, y, and z of the derivative or integral depending on what you're doing. Here is a practice problem for you guys. I will be right back. I have to see what the problem was. Hey guys, I'm back. So here is the practice problem. For the parametrized space curve, r of t is equal to cos 2t, t sine 3t. Give parametric equations of the tangent line at r of pi over 4. And part 2 is find the curve p of t that passes through the origin at t equals 0, and dp over dt is equal to r, or the derivative otherwise. And I'm not going to provide the solution. I'm only going to provide the final answer. So part 1 answer is will be x is negative 2s. Y is pi over 4 plus s. And z is equal to 1 over root 2 minus 3 over root 2s. Yeah, just use the L of s method that I did for the question I did earlier. And the second one, when you do it correctly, you should get p of t is equal to 1 over 2 sine 2t. One over 2t squared. And negative 1 over 3 cos 3t plus 1 over 3. And I double checked, these are the correct answers. So please give this question a try and let me know in the comments section if you're having any troubles, or email me if you will. So that's all for today. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.